All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying in this one, let's use the method of sections to determine the force in members AB, member BI, and member HI. So one of the first things that I do when I start one of these problems is I will put a tick mark on those ones that I'm looking for. So let's come in and get a mark set up. So member AB, member BI, and member HI. And I put that right in the middle of my member because it helps me remember when I come in and section through everything, I'm going to slice through the middle of my pieces in here. So from there, I want to take a look at that and say, do I need to find my support reactions? There's going to be times with method of sections where we can make our section free body diagram go around and not include any support reactions. This problem is not one of those. We'll have a later video that does do that, but we're going to have to find support reactions in here. So we'll come down below, and I've already put in the free body diagram just to move everything along. Hopefully at this point we're feeling really comfortable drawing those because they're going to keep showing up for everything. But we need to include in here, I had a pin at J, so I have a JX and a JY. I had a roller over here at F, so I put in an FY in here. If that gives me enough, I can find my support reactions. Let's just get this off on the side here. I can start and say, let's sum my forces in the X direction. That'll get me, well, I have 15 to the right at A, and I have JX going to the left at J, minus JX, and that's all of my X forces in here. This equals 0, which means JX is 15 kilonewtons. I assumed it went to the left before in my free body diagram. I get a positive number out from this, which means I assume the correct direction. It is going to the left. It's not one of our answers, but we need that to be able to work through our problem. From there, let's sum moments at point J. That'll get rid of JX and JY. It'll let me find FY out for this. So I'm going to say with positive going counterclockwise, let's sum my moments up about point J. This will get me FY times 2.4. 1, 2, 3, 4 times. 2.4 times 4 is 9.6. So 9.6 is my distance times my unknown force, Fy. That would be a counterclockwise moment, so we'll put it as positive. My 12 kilonewtons at H is going to cause a clockwise rotation, so minus my force is 12 times my distance is 2.4 plus 2.4, 4.8. Times 4.8. And at A, I have a 15 kilonewton force. It would also cause a clockwise rotation, so minus force is 15 times my distance, 1.8. Times 1.8 gets us to 0. If I solve that for Fy, I'm going to get here that Fy is equal to 8.81 kilonewtons, and I get a positive number out from this equation when I solve for Fy, so I guessed the right direction in my free body diagram. It is going up. And then finally, our last thing with Fy known, let's just sum forces in the Y. I'll get my final unknown support reaction, JY. Summing our forces in the Y direction. I have JY going up. I have 12 kilonewtons coming down, and I have Fy going up, plus 8.81 is going to get me to 0. Which if I solve for Jy, I'll get that Jy is a positive 3.19 kilonewtons. Which means if I get a positive from my equation, it's in the direction I assumed in my free body diagram. It's going up for everything in here. But that would be my 3 unknowns that I actually need as I come in and tackle that. From here, we're ready to move into that method of sections part for everything. So I'm going to come in and I want to slice through my truss. I'm going to try to cut through all of my members. Sometimes I can't do that. I can only cut through 3 unknown members because I have 3 equilibrium equations. For this one, I can make a diagonal cut here that goes through, I'm going to change the direction on that, goes through all of my members in here, cutting right in at the middle of all of them. But so let's come in and draw that in. I'll use green. But I can cut through AB, I'm going to use a wiggly line for my cut lines. So I'm cutting member AB, member BI, member HI. All three of those will be unknowns in my section free body diagram. These I worked with the overall free body diagram. I'm making a new one here. So I slice through this, and then I get a choice. I could either circle around to the right edge of this and include everything to the right of that slice line, or I could go to the left with it. The two things I look at in here are how many forces will I include in there. If I go to the right, I have 12 kilonewtons and a roller, 2 forces. If I go to the left, I'll have JX, JY, 15, 3 forces. It's about the same amount of work either way there. The second thing I would look at for that is which is going to be easier to draw. If I circle to the left, it's a much smaller drawing than if I circle everything over to the right, include from my cut line all the way to the right edge of that truss. I'm terrible at drawing things, and it takes me a long time to make a nice picture. I would say the lazy approach here is to circle to the left, and we always want to take the lazy approach with this. So we're going to come in and circle around to the left with this. So I close out my circle. I have to cut that pin at J. I have to get to the end of my cut. Anything inside this circle, my forces, my members in here, are going to show up and be included. Any member I didn't cut, like AI, JI, AJ, will just be a full member in my free body diagram. Any member I cut through is going to be an unknown that I'll show in tension. Everything outside that circle disappears. I don't need it in my problem from here out. So let's come down below and we'll draw that free body diagram. So I have, let's get my uncut members first. AJ, JI, AI. Just a triangle is really all that I'm drawing here. This is my section free body diagram for everything. So I have AI, or AJ, IJ, AI. That's my uncut members in here. From there, it's just starting to put in forces on that. I know at J, I need to have JX and JY. JY goes up, and it was 3.19. JY is 3.19 kilonewtons. JX, we found up above, went to the left, 15 kilonewtons. So we'll label that in there. JX equals 15 kilonewtons. And up at the top, there was a known force of 15. Going to the right, 15. Notice what we're not including in here. I didn't put in Fy in here. Fy was cut away from this. It doesn't show up in this section circle. The roller isn't in there. We don't need to include it in this setup then. Which means I could have actually avoided finding Fy, and it would have been a totally valid approach. If I had just some moments at F, I would have immediately found JY, and I could have moved on to this point then. But it wasn't terrible to find Fy. If you're unsure on it, go ahead and find it. It's probably worth the time to do it. I know my vertical distance on this is 1.8 meters. My horizontal distance here is going to be 2.4 meters. So we'll get both of those labeled in here. Also, I need my cut members. I cut member AB. So coming away from my uncut pieces, I need to show those. Coming away from, I cut between A and B, so I'll show that as a force. Leaving A, drawing an arrow out towards B, I have the force in member AB. I also cut through member BI. I don't want to show that up here at B because I didn't cut it there. I'm cutting somewhere in the middle of that. Beyond the cut is gone. So I want to draw that coming from I, coming straight up. I'll have an FBI in here. I will label, though, those two forces come up and intercept right here at point B. And I label that because a lot of times that's a great place for me to sum moments at. Because I can immediately say, well, I'd eliminate FAB and FBI. It's going to make it easier to find an unknown. Look for those points where you intercept at. Label them. It'll make it easier to do the rest of your problem. But our last unknown I want to put in here is, as I leave I cut member HI. So going to the right, I'd have F, H, I. Three unknowns, FAB, FBI, FHI. I have three equilibrium equations. I can sum forces in the X, in the Y, and I can sum moments. So I can get through all of those. So let's come and just tackle that. Right now, I have one unknown in the y direction. Let's start there. Summing forces in the y. I'm going to have FBI goes up, the force and member BI. I have JY going up plus 3.19. And everything else is in the x direction. So that equals 0. Which means when I solve for FBI, I'm going to get a negative answer. FBI is negative 3.19 kilonewtons. That was negative when I assumed it was in tension. If I get a negative answer, let's come in and put in a dashed arrow on our free body diagram. Again, that's just to help us remember we originally assumed it was in tension. We now recognize it's really in compression. Our solid arrow is what we originally used. That dashed one is, if I need to use this again, let's use it in any new equation in this updated direction in here. Then we'll come back to our answer and report this as a positive. FBI is really a negative in tension, is the same thing as a positive 3.19 kilonewtons in compression. So we drop that negative, change the T to a C. And that's going to be our first answer for the problem. Our next piece, I still have two unknowns in the x direction, so I'm going to have to do moments in here. I'm actually going to tackle moments twice for this. But let's do moments here at B. That would eliminate FAB. That would eliminate FBI. Even though we found it, I still could have done this first, actually. It's also going to get rid of my 15 kilonewtons in the top left of this. So we're going to get rid of a handful of things. Both positive, going counterclockwise. Let's sum up our moments about point B. Doing this, I'm going to have, well, FHI will cause a counterclockwise rotation, and it's 1.8 meters away. So 1.8 FHI. Again, we get rid of my 15, and FBI and FAB all have their line of action pass through B. We don't include them. So I need to come down to J. JX will cause a clockwise rotation, so minus my force is 15 times my distance here, 1.8. And then minus my moment from JY, because it will also cause a clockwise rotation. Minus JY, force, 3.19, times my distance, 2.4. Is going to get me to 0. If I solve that for FHI, I'll get a positive, which means we are in tension. FHI works out to be 19.25 kilonewtons in tension, which would be my second answer for this. Finally, I could come in and sum forces in the X to get FAB, or I could do moments again. I'm going to come in and do moments a second time. Let's sum moments down here at the bottom right corner at point I, because we'll get rid of a bunch of our unknowns there. Also, if I do moments here, then every equation I technically could have done in any order. It doesn't matter. I don't need to use FBI or FHI in a following equation. It just limits my chances of making a mistake that compounds through all of my work. So I'm going to come in and do moments at I. With positive, going counterclockwise, let's sum up our moments about point I. If I'm doing that, I can eliminate FBI, FHI, and JX. I'll have moment from FAB, my applied 15, and JY. So this will get me, if I start at FAB, it's going to cause a clockwise rotation, so negative 1.8, my distance, times my force, FAB. Then I can come in and say my next one would be, let's get that 15. It'll be minus, because it'll also cause a clockwise rotation, minus 15, my force, times my distance here, 1.8. And my moments about B, that 15 was from JX. Here, this is from my applied force. And then finally, my last thing, I have JY in here, causing a clockwise rotation, so minus JY, 3.19, times distance, 2.4. Which is the exact same as it was in my moment about B equation. But all of that is going to get me to 0. If I solve for FAB, I'll get my last unknown. FAB will be equal to negative 19.25 kilonewtons. That was negative when we were in tension. So let's change that arrow around. We're really in compression. Let's get that updated direction arrow in there. And the report is a positive. FAB is a positive 19.25 kilonewtons in compression. Which would be our final answer for that one. If I come in some force in the X instead of moments a third time, that would have been a valid approach for us. I would have had 15 plus FAB minus 15 plus FHI is 19.25 is 0. And FAB would have to be 19.25 for that to work out. We'll get the same answer. There's different approaches to these problems. Don't feel like there's one correct solution. Choose something and go with it. We'll get you there. But hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around. Let's get you an A with JJ.